Okay, here we go. Got another topic for you in the realm of spatial thinking and geometry. So today what we're tackling is parallels and transversals, and this is related to what we talked about with angle relationships in the last lesson. So let's kind of refresh our memory though on what are parallels. Remember, parallels are two lines that are parallel to each other that run alongside each other. They both go in exactly the same direction, so they never crisscross each other. They never intersect. All right? So I've got two parallel lines here. It could be like two streets that are running in the same direction that never crisscross each other, right? Well, we know that when you drive on a street, eventually you come to an intersection. Let's say that you have another street that cuts across those streets, and it does it at an angle. Okay? If it cuts across those streets, and a fancy word for cutting across would be to transverse or to traverse, but we call this line that cuts across a transversal. And a transversal is just geometry's word for a line that cuts across two other lines. Okay, so that green line is called a transversal. It cuts across the two parallel lines. And you might notice that what you have when you cut across those two parallel lines is you created a bunch of angles, didn't you? There's actually 8 angles here. See them all? Okay, I want you to try to make a conjecture, an educated guess, about which of the following 8 angles might be congruent, which means equal, to angle 1. Take a look at these 8 angles. Would angle 2 equal angle 1? Would angle 3 equal angle 1? Would angle 4 equal angle 1? Or maybe angle 5 or 6 or 7 or 8? Which of them would equal angle 1 and which of them wouldn't? Okay. Well, yesterday we actually answered that in the video about angle relationships, partly, because we said that vertical angles are congruent. Vertical angles are equal. And angle 1 is a vertical angle with angle 4, because they're across from each other on that little crisscross of those two lines. So we know angle 1 is congruent to angle 4. But when two parallel lines are cut by a transversal, corresponding angles are also congruent. I'm going to tell you what I mean by corresponding angles in just a second, but what I want you to do is look and see that angles 1, 2, 3, and 4 are kind of in one little angle cluster, and angles 5, 6, 7, and 8 are in another little angle cluster. And if those two black lines are parallel, wouldn't the green line hit the first black line at the same angle that it hits the second black line? So that angle 1 and angle 5 should be corresponding to each other. So corresponding angles are any two angles that are both in the same position. What I mean by that is like how angles 1 and 5 are both in the upper left of their angle clusters. So angle 1 and angle 5 are going to match each other. Angle 1 and angle 5 are going to be equal. Angle 1 and angle 5 are going to be the same. Angle 1 and angle 5 are going to be congruent. That means that angle 4 and angle 5 are also going to be congruent. Since 1 is congruent to 4, 1 is congruent to 5, 4 must be congruent to 5 as well. By the way, angle 4 and angle 5 are inside the two parallel lines on the interior, and they're on alternate sides of the green transversal. So sometimes you might hear those called alternate interior angles, but let's not worry about that too much. There's still one more angle here that's congruent to angle 1. And it's not angle 2, and it's not angle 3, and it's not angle 6 or angle 7. It's angle 8. And you might already be seeing why angle 8 is congruent to 1 and 4 and 5. There's a couple reasons. First of all, angle 8 is a vertical angle with angle 5. And if 1 equals 5 and 5 equals 8, then 1 equals 8. Also, angle 4 and angle 8 are corresponding angles. So if 4 equals 8 and 1 equals 4, then 1 equals 8. So actually, angles 1 and 4 and 5 and 8 are all congruent to each other. That's kind of cool. But there's more. Angle 2 is corresponding to angle 6, and angle 2 is equal to angle 3, and angle 6 is equal to angle 7. So all the blue angles there are congruent, and all the red angles are congruent. Or a better way you could say this, if you want a good, easy way to remember which of those 8 angles are equal, would be to say that all of the acute angles are congruent. Oh, that kind of makes sense, right? And all of the obtuse angles are congruent to each other. Okay, but there's more. What about angle 1 and angle 2? They're obviously not congruent because one is acute and one is obtuse, but don't they make a straight line if you put them together? Oh yeah, so any pair of one of the obtuse angles and one of the acute angles is supplementary. Supplementary means they add up to 180 degrees. So angle 1 and angle 3 are supplementary, angle 1 and angle 6 are supplementary, angle 7 and angle 4 are supplementary. Interesting. Remember, supplementary means they add up to 180 degrees. Okay, so here's what I want you to do with all this. I want you to take this diagram and see if you can figure out what all the different angles here are. There's 8 of them, and I only gave you one, but you should be able to use that one angle to find all 7 of the other angles. Okay, then for practice problem number 2, I want you to just look at this diagram and name a pair of corresponding angles. So pick 2 angles that correspond to each other. Maybe it's the 2 angles that are in the upper left of their cluster, maybe it's the 2 angles that are in the lower right of their cluster, but pick any pair of corresponding angles and name them. Okay, also name 2 angles that are not congruent to each other. So just pick any 2 angles here that don't have the same measurement. That's all we got to do. So